Good afternoon from the School of Education and the COOL Lab, our interdisciplinary teaching learning lab for computational thinking and digital education. I'm professor for Instructional Technology and Computer Science Education. And today I would like to introduce you to our COOL IT teaching approach and a different view on instructional technology and computer science education. After defining the framework, I would like to introduce you to the teaching approach and our possibilities and intentions to interweave computer science with any other subject. And I will give also some examples of practice. Then I will show you two quite unusual strategies or instructional technologies that allow to interweave computer science with foreign languages. The one is modeling. It comes from computer science education or from computer science and can support learning in foreign languages. And the other one is a linguistic concept, a linguistic strategy called translanguaging, which shall connect languages to computer science and support learning in computer science, especially in programming education. Instructional technology is often seen as the use of technologies in school or in or digital education and so on, but it is really more. So our view is as follows. First of all, what we have in the title, COOL is an acronym of Cooperative Cross-Curricular Open Learning or Computer Science Supported Open Learning, and sure, also cool in the sense of interesting, motivating, game-based, useful, and so on. The acronym IT refers to instructional technology on the one hand in a wide sense, and on the other hand on informatics teaching, mainly computer science education at school. And today, when I talk about computer science education, I mainly refer to computational thinking, all thinking processes of computer science and problem solving. Educational technology, instructional technology are used as synonyms, so it's more or less the same. I use it in a wide sense, technology not only as hardware or certain strategies, but really as all methods that can improve learning in any domain. It comes from the Greek word technology, a systematic treatment of an art, craft, or technique, a system or method of making or doing. So instructional technology is a systematic way of designing, carrying out, and evaluating the total process of learning and teaching, employing a combination of human and non-human resources, always with the aim of improving instruction and learning. What we use in our work is this definition of educational technology. For us, it is the use of all pedagogical approaches, instructional strategies, media, tools, and technologies to consistently improve learning, instruction, and performance. So what is different to other authors and researchers who are dedicated to instructional technology? We have an interdisciplinary two-in-one approach to computer science education that really interweaves the contents of computer science with those of other subjects, always aiming at killing two birds with one stroke, which means that we acquire two subjects at the same time, or we acquire competencies of two subjects at the same time. This is possible when we follow our COOL IT approach. I would like to show you how we can interweave computer science to other subjects. On the right side, you can see one example from a workshop with children. We focus on text comprehension and language learning and combine that with computer science, concretely here with logic and truth tables. There was The basis was a short text that the children could read or hear, and then they had to build their own truth table with these cards that you can see here. So this is one strategy from computer science that can really support learning in language lessons. The cool IT teaching approach has been developed more or less during my habilitation, but concretely, I have been developing it since my beginning at school 20 years ago, when I started to combine my subjects, foreign languages and computer science. And so this concept is on the one hand based on research, certainly on neurodidactics or how the brain learns and effective teaching methods. But on the other hand, it is based on my personal experience in teaching in secondary schools, in teacher education, and also teaching adults. We implemented this teaching approach not only in our research, but in school, in our cool lab, and also in my master and bachelor courses. The research interests related to cool IT are mainly how can we convince and help teachers without computer science background to integrate computational thinking or computer science in their domain, which is necessary due to our curriculum basic digital education, because not always there is a special subject for that, and teachers of English and German or whatever have to teach computational thinking without any or without preparation. The other aim is to promote, enrich, and facilitate computer science education from kindergarten to university. So we want to know if we can improve understanding and learning on the one hand in different subjects by using computer science methods or concepts like modeling or logic, as I already told you. And on the other hand, in programming education by using language-related strategies, for example, translanguaging or think aloud. So convincing teachers is really necessary, but it is not so difficult. It's easy when we pick them up where they stand, where they are, regarding their competencies, regarding their lesson plans they have. Then it is possible, and we can integrate computational thinking. As you can see here, this was a workshop for a fashion design class, where we introduced several basic concepts of computer science, like algorithms, directly into the task that they had to do for fashion design. So now the two methods, the one modeling from computer science, which is a visualization strategy, a learning strategy that can support other subjects in this case now languages, and the other one translanguaging from linguistics, which is introduced in computer science to improve programming. Modeling is a language, as you know, and it is really perfect to be combined with languages, as you can see here in this diagram. In order to have something to check which competencies the students and teachers should acquire when they use modeling, we developed a reference framework for modeling. It is based on the Common European Framework for Language Learning. Here you can see that we really go from simple visualizing strategies from mind maps on over computational thinking to modeling in the sense of preparing programming in computer science. So really from visualizing in general education to modeling in computer science. Here, one sample activity. This was a very long text in an English class of secondary education about the procedure of how a new law passes the House of Commons and the House of Lords in Great Britain until it is really approved. And the students and the teacher too told us that it's really easier to understand such an activity diagram with the single steps than to read a very complex text. It's really a manifold topic, modeling. So we have several aspects that we study. Therefore, also the methods used, the research designs are manifold. On the one hand, we use design-based research with a citizen science focus for the development and evaluation of teaching materials together with teachers or students. And on the other hand, we investigated acceptance and usability of modeling as a strategy for mainly its beginning when it was unknown to the teachers. And the impact of modeling on learning outcomes. There we have mixed methods design and experimental design. Some selected results. We have done already several projects with totally more than 400 students and teachers where we investigated different aspects. And the main results that are also useful to convince new teachers to try out our strategies concerning acceptance. It is high, but only after convincing teachers by showing them several really basic examples. One sentence that I often use is even children in primary school can do that, so it is really not difficult. Then it is okay, then we get the feedback, it's motivating, creative, useful, easy to learn, but only abstraction is difficult. And the teachers, mainly the teachers, the students know, the teachers have fear of mistakes. Regarding the usability, we checked what is really usable for people without computer science background. And there we could see that mainly entity relationship, class, use case diagrams for structuring learning contents were useful. And for visualizing rules and procedures, for example, grammar rules in English, activity diagrams could easily be integrated. And the current work in progress is a bit late because due to COVID-19, we could not do anything in the last 3 semesters. Now we do that. We had a first round of a Russian vocabulary experiment in secondary education, where we check if children prefer learning with class diagrams and categorized vocabulary confronted to basic black and white vocabulary lists. On the one hand, preference, and on the other hand, if there's really an impact on the learning outcomes. And we are glad to say that with 71 students, we could have the result that the recall performance was really higher when they first learned the grouped vocabulary in class diagrams than with the black and white lists. The last strategy, and then I come to the end, is more or less an outlook, because we are really at the beginning, translanguaging, which is simply the use of 2 languages to achieve one goal. It's a pedagogical practice in bilingual education, where the teacher who uses the stronger language to develop the weaker one, and that can result in increased proficiency in the two languages. So this is related to languages, but we hope to transfer that into learning a programming language. I did that without knowing that this concept of translanguaging exists in our brain-based programming project in 2012. We mixed up Java code, pseudocode, natural language, and modeling in order to describe and analyze the problem and the task they had to code. That was only in one bachelor programming course with 32 students. In the observation and interviews, they told me that they found it a good learning method, a good way of solving problems. The motivation to finish the tasks, even if students were not able to implement them really in Java code, that was higher. For the teacher, this is a little bit more work because you have to evaluate that in two steps. The first one is only, can the students understand the problem and deliver a draft for solutions? And this can be in natural language, in pseudocode, in a form of modeling. And on the other hand, the last one is then the Java programming language, the Java code. And this is clear, when it is running, it's running. And this is what we will do in the next time. On the one hand, we continue our work in modeling, which is really a useful, practical instructional technology or strategy. We will further develop our reference framework and test it in several contexts and situations. And we continue the work on the impact on learning outcomes. And in the summer term 2020, it is planned to investigate translanguaging as a learning strategy in a Python course for beginners at JKU. I thank you very much for your attention, and yeah, I'm open for questions.